Okay, now we're doing problem 53, a vector A that has a magnitude that's 10 units, and another vector B that has a magnitude of 6 units. They differ in angles by 60 degrees. So you have vector A that has a magnitude, so magnitude, I'm just drop the vector sign. So you have A that has 10, and your B that has 6. And the angle between them, is 60 degrees. And you want to find the scalar product of these two vectors and the magnitude of the vector product. So in other words, you want to find A dot B and A cross B, the magnitude of A cross B. So these are very easy to do because you have vector A, vector B. The angle between them is 60. So based on the formula for the scalar product, that would just be A magnitude A times the magnitude B, and then times cosine of the angle between them. So in that case, you have 10, you have your 6, and then times cosine of 60. So you should get a value that is equal to 30. That's easy. What about A cross B? So A cross B, if you just want to find the magnitude, it's also very easy. It's just A times B and then times sine of the angle between them. So 10 times 6 and then times sine of 60. So you should get 52. Okay, so this is a very simple problem that illustrates how you calculate the scalar product and the vector product, which you're going to use it throughout the physics 211 and even through physics 212, because we use a lot of the scalar product and the vector product. So make sure that you know how to use them. Okay. Now the last problem I want to do from this chapter is problem 56. All right, problem 56. Find the scalar product, let's see. Problem 56. Find the sum of the following four vectors in unit vector notation and magnitude and angle relative to positive x-axis. So we have P, vector P, that is 10 meters at 25 counterclockwise from the from the positive x-axis. So it's 10 meters at, so I'm just going to use this symbol at 25 degrees counterclockwise. So that will be that. And then your Q is 12 meters and counterclockwise from the Y. So that is 10 counterclockwise from the Y. And your R, your vector R has a magnitude of 8. And it is making the angle 20 degrees clockwise from the negative Y. And your S is equal to 9 and set at 40 degrees and counterclockwise from the negative Y. Okay, so all these are just like symbols to make you aware of where the vectors are positioning. So what we need to do is actually draw those vectors on XY plane, so you'll be able to express them in unit vector notation and then find out the sum of these four vectors. So your P, where is your P? Your P is making 25 degrees with the x-axis. So this is your P, vector P, okay? And then your vector Q, that's positive Y and then 10 degrees. So this is your 25 here, and this is your Q, and that is 10 degrees from the positive x-axis. And then your R is from negative Y and then clockwise. So this will be right here. This is your R, and this is your 20 degrees. And then your S is counterclockwise 40 degrees. So this is your S, and that's 40 degrees. Okay, so once you draw them on the on the X and Y axis, then it becomes easy for you to deduce in unit vector notation. So I'm just going to, so this has a magnitude. I'm just going to write here. So that's 10, and this is 12, this is 8, and this is 9. So then I'm going to erase this, and then based on the diagram, I can easily deduce the X and Y component. So your P has a vector that is 10, and remember, this is just small, the x component. The x component is just, it's just this. So it's just the 10 times, so let me just write here. 10 times cosine 25 I hat, and then your y component. Your y component here is plus 10 times sine of 25 and then j hat. Okay, so your p can be easily calculated, and I don't have the value, but you can punch into a calculator very easily. So what about your next vector? That's your q. So your q here has a magnitude of 12, and then you can see that this, I'm going to use all small angles. So this is 10, so it has a negative value. So you need to manually put a negative sign in front of it. The magnitude is 12, and then the angle. So the x component is opposite the angle. So you will have sine of 10. And then your y component is adjacent to angle, so that's your cosine, and it's positive. So it's plus 12, and then cosine 10. And then j hat, okay? This is I hat, and then plus j hat. And then the next vector is your r. So vector r is equal to, it has a magnitude of 8, and you can see that this is in the third quadrant, so it has a negative value for both the x and y components, so you need to manually put a negative sign of it, and then 8. Now the x component, if we're using this angle, the x component here, that is opposite, so you should use sine. So sine of 20 degrees, okay, I hat, and then minus 8, and then the y component is adjacent to the angle, so that's your cosine 20, and then j hat. Now that's down to the last vector, your s, which has a magnitude of 9, and then you can see that the x component is positive, but the y component is negative. And the x component here is opposite of this angle, so it should be sine. So you have positive, and then 9, and then sine of 40 degrees, I hat, and then your y component is adjacent, and it's negative, so it's negative 9, and then cosine 40, and then j hat. So after you punch in all these numbers, and then you should, you just do a vector sum. So add, then that gives you add all the x components together, you add all the y components together, you don't cross adding them. So what you're going to get is this. So the sum is equal to positive 10 I hat, and then plus 1.6 j hat. Okay, so that will be in unit vector notation. So that is that. So in addition to that, you also find what is that in magnitude and angle notation. So you need to utilize this information, mark it on your xy axis. So you have the 10 here. So you have, let's say 10. This is your x component, and your y component is this. They both are positive. So you should have a vector that's right here, and take that to be angle theta. And you can see that this is in reference to, so the magnitude becomes easy because the sum would just be equal to your 10 squared plus 1.6 squared. So after you do the calculation, you should get 10.13 meters. Angles, easy because you can just use the tangent theta, and because they are both in the first quadrant, so tangent theta is no problem. And then this angle, opposite here you have 1.6, and adjacent you have 10, so your angle theta here, you will get 9.1 degrees. Okay? So this is a simple exercise that tells you that when you have a different vectors, you want to draw it on the xy plane, so you will understand a lot more better about which quadrant the vector is, is pointing, and so forth.